The remarkable part is that all of these processes work as one continuous cycle. Cut the ground, remove the material, push forward, and prepare the tunnel behind. Then the process starts again, meter after meter, sometimes for kilometers. Most modern tunnel boring machines install precast concrete segments to create a strong circular lining. Each segment is manufactured with extreme precision so the pieces can fit together and form a complete ring. Eventually, after months or even years of excavation, the TBM reaches its destination. The cutting head breaks through the final section of ground, connecting the newly constructed temple world or another underground structure. After the ground is broken apart, the material falls into the excavation chamber. From there, specialized systems collect it and send it toward the rear of the TBM, where it can be transported out of the tunnel. Once the TBM is positioned, the cutting head begins to rotate. Hydraulic cylinders push the massive machine against the tunnel face. The cutters break the ground, and the excavated material is pulled into the machine to begin its journey out of the tunnel. And this is what makes a TBM so remarkable. While the front is digging into untouched ground, the machine is simultaneously removing material and constructing the tunnel behind it. It's essentially a moving underground factory. As the TBM continues forward, the completed tunnel grows behind it. Ring by ring, the machine can create tunnels stretching for kilometers beneath cities, mountains, and waterways. Deep beneath cities, mountains, and rivers, enormous machines can carve tunnels through solid ground. These machines are called tunnel boring machines, or TBMs. But how can a machine this massive continuously dig through the earth without collapsing the tunnel behind it? But how does a machine weighing thousands of tons move forward? Powerful hydraulic cylinders push against the tunnel lining behind the machine. Their enormous force drives the TBM forward into fresh ground. A tunnel boring machine is far more than a giant drill. It cuts the ground, removes thousands of tons of pressure, pushes itself forward, and builds a permanent tunnel behind it all at the same time. Inside the TBM, a powerful hydraulic arm called a segment erector picks up each concrete piece. It rotates and positions the segment with millimeter-level precision, gradually building a complete ring around the tunnel. Removing the ground creates a new problem. The tunnel must remain stable. Without support, surrounding soil and rock can shift inward. That's why the TBM builds the permanent tunnel structure almost immediately behind the excavation. One by one, the segments come together until they form a complete ring. Seals between the joints help prevent groundwater from entering, while the interlocking structure creates a strong circular tunnel lining. One of the most important jobs is getting the excavated material out. In many hard rock TBMs, conveyor belts continuously carry the crushed material away from the cutting head and toward the surface. A TBM is really an entire underground factory. Its front cuts the ground, its systems remove the excavated material, hydraulic cylinders push the machine forward, and another section installs the tunnel lining behind it. Underground pressure can be enormous, especially beneath rivers or cities. Some TBMs control pressure at the cutting face so surrounding soil and groundwater remain stable while excavation continues safely. A TBM must follow an extremely precise route underground. Laser guidance, sensors, and computer systems constantly monitor its position. If the machine begins drifting from the planned path, hydraulic steering systems can make tiny corrections. At the front is the cutting head. Depending on the ground, it can carry dozens of powerful cutting tools. As the enormous disc rotates, these cutters press into the ground and break the rock or soil into manageable pieces. Digging a tunnel is far more complicated than simply removing soil. Engineers must deal with rock, groundwater, underground pressure, and existing infrastructure. The tunnel also has to remain stable while thousands of tons of material are being removed. As the cutter head rotates, its cutting tools continuously fracture the ground. The machine doesn't remove one enormous piece of rock. Instead, it breaks the material into thousands of smaller fragments that can be transported away.